Hi everybody, good morning to all of you. Today I am recording the lesson for the day 18. Today we will solve some of the examples on the Lami's theorem and also the resolution of forces to find out the resultant by resolution of forces. In the last class we have been discussing about the problems on the resolution of forces and Lami's theorem. So that we will continue, and here first we will see the problems on the Lami's theorem. Next we will go to the problems on the resolution of forces. Now I am sharing the PPT. So in this class we are going to discuss about the problems on the Lami's theorem and also resolution of forces, and these problems we have already discussed. Now the Lami's theorem also we have studied, and we know that Lami's theorem is applicable when three forces are acting and are in equilibrium condition. Then in that case each force is proportional to the sine of the angle of other two forces. That is, each force is proportional to the sine of the angle between the other two forces. And according to this, if ABC are the forces and alpha, beta, gamma are the force angles, then A by sine alpha is equal to B by sine beta is equal to C by sine gamma. Here, when the force A is taken, the angle between the B and C and so on will be considered. So this is the Lami's theorem equation, and based on this we will solve some problems. So this is the actual equation, mathematical form of the equation is A by sine alpha is equal to B by sine beta is equal to C by sine gamma. And this is also we have solved in the last class. Now this is a problem. We'll start from this problem. So take this problem. An electric light fixture weight 30 newtons hangs from a point O by two strings OA and OB as shown in the figure. Determine the forces in the strings. So here this is the problem, and with the figure it has been given. Here an electric light fixture, some weight of 30 newtons is hanging by the two strings from point O. That is, the O is the meeting point, and we got the string OA and the string OB. Now here the angles are given in the figure, and based on the angles and the weight we are supposed to find out the forces or the tensions acting in the strings. So this is the problem. Actually, here the figure is given. The figure A, the two strings OA and OB are supported by the horizontal beam and vertical wall. And now the picture is, that is the electric picture of some given weight is hanged by the two strings. So now the angle is given. Here OE is making an angle of 45 degrees with vertical wall, and the string OB is making an angle of 60 degrees with horizontal beam, and the weight is given as 30 newtons. Now we have to estimate the tensions in the strings OA and OB. Then nothing of the forces of the tensions. Now here we'll go to the solution part. In this, firstly we have to write down the given data. So as per the problem, this is the given data. First, the weight of the electric light fixture W is equal to 30 newtons, and let the tension in the string OA is equal to D1, and the tension in the string OB is equal to T2. This we have to count, and the angles are also given. So these are the angles given. That is, OA is making an angle of 45 degrees with vertical wall, and OB is making an angle of 60 degrees with horizontal beam. Now, by using the geometry of the given picture here, the AOB is one of the triangle. So the triangle is repeated as it is with the given angles, and then with that we can able to find out the remaining angles, and then we can apply the Lami's theorem. So to apply the Lami's theorem, the first part is we should know the angle between the first and second force, second and third force, and first and third force. So the angle between the forces is needed. So to find out the angle between the forces, we should make use of the geometry of the given figure with the angles. Now if you see here, the angle, that is OA, is making an angle of 45 degrees with vertical. So similarly, the OA also makes an angle of 45 degrees with horizontal also, because the angle between the vertical and the horizontal is 90 degrees. Therefore, the angle made by the OA with horizontal, it is also equal to 90 minus 45. This is equal to 45 degrees. Next, coming to the OB. So the OB is making an angle of 60 degrees with horizontal. Okay. Now, the triangle OAB, when you consider the triangle OAB, one of the angle is 45 degrees and the other angle is 60 degrees. So what will be the remaining angle? We know that in any triangle the sum of angles is 180 degrees. So we know the two angles. The third angle can be found by subtracting the value of sum of the two angles from 180 degrees. So here the two angles are 45 and 60. So it is equal to 105 degrees. Therefore the third angle is equal to 180 minus 105. So that is equal to 75 degrees. So therefore now the angle between the forces OA and OB. Here the angle between the two forces OA and OB will become the 75 degrees. And that is one, one angle we have found. Next, if we take the angle between the OA and W, so this OA and W, if you draw a imaginary straight line, that is imaginary vertical line at point O, what is happening? So the total angle will be 180. But this angle you know, it makes an angle of 45 degrees with vertical. So the angle between the OA and W will become the 180 minus 45 degrees. So the angle between the OA and W will become the 180 minus 45 degrees. Similarly, the angle made by the force OB with vertical is equal to 30 degrees. Therefore, now the angle between the OB and W will become 180 minus 30. So now we got the three angles, that is the angles between the forces. Now we know that OE is nothing but the force in the string OE is nothing but the T1, and whereas the force in the string OB is equal to T2. Now we are representing the same force diagram. The force diagram is drawn in the figure B. The figure A is the given problem, and with that help of that figure A, we have found the angles, and we have drawn the force diagram in the figure B. Now here we got the three forces T1, T2 and W. So the W is acting vertically downwards. T1 is to the leftward, the tension in the string OA, and T2 is acting rightward, that is tension in the string OB. Now we know the angles. The angle between the T1 and T2 is equal to 75 degrees, and the angle between the T1 and W is equal to 180 minus 45 degrees, and the angle between the T2 and W is equal to 180 minus 30 degrees. Now we know the one of the force and angle between the other forces. Then so we can apply the Lami's theorem. So to find out the tensions T1 and T2. Now by applying the Lami's theorem, we know that when the here what is happening is the picture is supported by the two strings, and here actually three forces are acting. Here the weight of the picture is acting vertically downwards, and due to this the tensions are developed in the string OA, that is T1, and the tension in the string OB, that is T2. So because of the action of the three forces, that is T1, T2 and W, the picture is at a equilibrium condition. Now hence we can apply the Lami's theorem, and by Lami's theorem we know that the from the force diagram W by sin 75, W by the sine of the angle between the other two forces. So yeah, for the W, the other two forces is T1 and T2. So W by sin 75 is equal to T1 by sine of 180 minus 30. That is, if it is for the force T1, the other two forces will be the T2 and W. So that is equal to 180 minus 30. And next T2 for the force T2, the angle between the other two forces will become the T1 and W, and that is equal to 180 minus 45 degrees. Therefore, according to the Lamb's theorem, W minus sin 75 is equal to T1 by sin 180 minus 30 is equal to T2 by sin 180 minus 45 degrees. Now here, to find out the T1 and T2, we have to equate T1 with W, the first of the equation, and also the T2 and W separately. So by equating the T1 by sin 180 minus 30 is equal to W by sin 75. So here sin 180 minus 30 is nothing but the plus sin 30. Therefore T1 becomes W into sin 30 by sin 75. So T1 is equal to 30, that is the W value, into sin 30 by sin 75. So if you substitute the values, we will get T1 is equal to 15.53 newtons. So this is the tension acting in the string OA. Similarly, equating the T2 by sin 180 minus 45 degrees is equal to W by sin 75. Here also sin 180 minus 45 is nothing but the sin 45. Therefore, T2 will become W into sin 45 by sin 75. So by substituting the values, it is equal to T2 is equal to 21.95 newtons. So this is the tension in the string OP. Now the answer is the tension in the string OA T1 is equal to 15.53 newtons, and the tension in the string OB is equal to T2 is equal to 21.95 newtons. So actually what is happening is here 30 newtons is hanging by the two strings. However, the angles made by the strings with horizontal are different. That is, in the one case it is 45 degrees, that is in the T1 it is making an angle of 45 degrees with the horizontal, and T2 is making an angle of 60 degrees with the horizontal. Therefore, due to this variation of the angles, the tensions, the different magnitudes of the tensions are developed. So therefore the T1 and T2 are different. Now, so this is the problem the language. So like this, we have to solve in case of the language theorem. Firstly, we need to find out the angles by using the geometry of the given figure. We have to find out the angles between each of two forces, and after that we can draw the force diagram, and then by using the Lami's theorem, then we have the equation, we have to equate the equation, and we can find out the unknown. Generally we are supposed to find out the tensions or the forces developed in the strings. So in this way we can able to find out the tensions in the strings by making use of the Lami's theorem. Next we will move to the other problem. So this is the problem. Here the similar thing, here also the load is given and the angles are mentioned in the diagram, and we are supposed to find out the tensions in the strings. Now take down this problem. A weight of 2 kilonewtons is supported by two strings as shown in the figure. Find the tensions in the strings. So this is the figure given. Here we got the two strings AB and BC, and a weight is supported. It is a weight is hanged by the two strings. Here the angles made by the strings are given as the string BC is making an angle of 45 degrees with the horizontal, and the string AB is making an angle of 30 degrees with horizontal, with the ceiling, with the top, we can say it is a horizontal line. Now we need to, here the W value is given as 2 kilonewtons. Now we need to find out the tensions developed in the string BC and also in the string AB. So for this, first let T1 is the tension developed in the string BC, and T2 is the tension developed in the string AB. Now with the help of the geometry of the given figure, that is with the help of the given angles, we are supposed to find out the remaining angles. So somehow we have to find out the angles between the forces, any two forces. Then we can easily apply the Lami's theorem to find out the unknown forces or the unknown tensions developed in the strings. Here at point B, for this at point B we have to draw a vertical line. So that is, we have to draw a imaginary vertical line. So if you draw the imaginary vertical line, so what happens? We will be getting the two triangles. So that imaginary vertical line makes an angle of 90 degrees with ceiling or with horizontal at the top. So in one triangle, that is the left side triangle, at point A the angle is 30 degrees and the other angle is 90 degrees. Then the angle made by the AB with vertical is equal to 60 degrees, is equal to 60 degrees. Similarly, the But in the here what is happening is the problem 30 taken means here what has happened is he has shown the 30 degrees in the problem, but it is equal to, you can take it as 60 degrees. So by mistake he has mentioned the 30 degrees, but we have to take it as the correct one is the 60 degrees at the point A. The angle made by the string AB with the ceiling, that is horizontal ceiling, is equal to 30, that is 30 given, but it is not 30, it is equal to 60 degrees. Therefore, the angle made by the string AB with the vertical will become the 30 degrees. The angle made by the string AB with the vertical is equal to 30 degrees. And similarly, the angle made by the string BC with vertical is equal to 45, because already we got a 90 angle and we got a 45 degrees. The other angle will become the 90 minus 45, it becomes a 45. In the other previous case, it is the string, the angle made by the AB with vertical is equal to 90 minus 30, it becomes sorry, instead of 30 we should take the 60, so 90 minus 60, so it will become the 30 degrees. Now when the angles are 30 and 45 degrees, then we can know the angle between the T1 and W is equal to 180 minus 45 degrees. Similarly, the angle between the T2 and W is equal to 180 minus 30 degrees, and the angle between the, so here the angle between the two forces is equal to, that is 45 plus 30, it becomes a 75 degrees. Now using the Lam's equation, so this is also similar to that of the, so when this is that was given as 60 and this is 30, now the angle between the T1 and T2 will become the 45 plus 30, it becomes 75 degrees. Now using the Lam's theorem, so we have to, so by Lam's theorem we know that W by sin 75 is equal to T1 by sin 180 minus 30, and T2 becomes T2 by sin 180 minus 45. Before that we will draw the force diagram. So now to find out the T1 and T2, we have to equate separately the T1 with W and T2 with W. So we know that T1 by sin 30 is equal to W by sin 75. Therefore, T1 is equal to W into sin 30 by sin 75. And we also know that the W is equal to 2 kilonewtons, 2.0 into sin 30 by sin 75. So by substituting the values, the T1 will become 1.035, that is kilonewtons. And now to find out the T2 value, so we have to equate the T2 with W. So that is nothing but the T2 by sin 45 is equal to W by sin 75, or T2 is equal to W into sin 45 by sin 75. So here also the W is given the same value, that is 2.0 kN. So by substituting the given values, T2 is equal to 2.0 into sin 45 by sin 75. So T2 is equal to 1.46 kilonewtons. So these are the answers. The tension in the string T1 and the tension in the strings T2 are found this way, and we can also apply the same procedure to find out the other problems in the Lami's theorem. So this is about the problems on the Lami's theorem. Now we'll go to the other problem, and this is a problem on the resolution of forces. Here the forces are also can be given in this way, because we got the directions north, south, west, east. So north means vertically acting vertically upwards, south means vertically acting downwards, west means horizontally acting leftwards, east means horizontally acting rightwards. So north, south, west, east will act along the x and y axis, and the sometimes the force also may be given like this, and we are in that case we are supposed to find the magnitude and direction of the given force system. So you take this problem, find the magnitude and direction of the single force that brings the following system of concurrent forces into equilibrium. The forces are, the first one, a force of 20 newtons acting due east. Second one, a force of 25 newtons acting 40 degrees at north of east. Third one, a force of 10 newtons acting at 50 degrees west of east. Fourth one, a force of 30 newtons acting vertically downwards. So these are the four forces given, and here what is the requirement, what they wanted to find out, and we are supposed to find out the magnitude and direction of a single force that brings the following system of concurrent forces into equilibrium. That means not the resultant. We are supposed to find out the value of the equilibrium. Means by definition, equilibrium is that force which will bring the system into equilibrium condition under the action of some forces. Here the four forces are acting on a body, and due to that they develop some resultant force. But however, we have to apply a new force so that the system will remain in the equilibrium condition. So that force is called as the equivalent, and that we need to find out. But by definition, equivalent is nothing but a resultant force which acts in the opposite direction. So the magnitude of the equivalent force also equal to the resultant force, but it acts exactly opposite to the direction of the resultant force system. Therefore, so firstly we have to find out the resultant of the given force system, and then after finding out the resultant, then we can find out the direction of the equivalent by drawing graphically, and then we can specify the magnitude and direction of the equivalent force. Now for the so now this is the force system here in the for your understanding point of view. In the figure A, the sides are shown. So north, south, west, east, east of north, west of north, south of west, north of west, west of south, east of south, south of east, like this we have given. So in this one, not only the forces mentioned in the problem, they can mention like this also. It's making an angle of 20 degrees in east of north. In that case, you need to take that 20 degrees in the east north, from north only. East of north means, so the angle must be from the north. Similarly, the south of west. In that case, in the southwest direction, you have to take the angle from the west. Like that, you have to take. Sometimes they may specify a force acting in northeast direction. Northeast means, so you know the north and east. So the if a line which divides exactly into two parts, or the angle into two equal parts, that direction is called as the northeast. In that case, so no need to give the angle. Northeast means we can say the 45 degrees, either from the north or from the east, in northeast direction. So like that you have to go ahead in the other problems. Now coming to the present problem. So let R be the result of the force system, and E is be the single force which will bring the system into equilibrium, and that is called the equivalent force, and it is nothing but the its magnitude is equal to the resultant, but it acts in the opposite direction. So first of all we have to find out the resultant of the given force system, then we can find out the equivalent. Now the force diagram, the with the given conditions is shown in the figure B. Here the F1 is acting. Here the what is the first force? The a force of 20 newtons is acting due east. So it is acting towards only east. Due east means along the east. That means the east is in the horizontal. So F1 is equal to 20 along the x-axis. Next, the second force is a force of 25 newtons acting 40 degrees in the north of east. So from east we should take the 40 degrees in the northeast. So in the northeast, that is F2 is equal to 25 newtons in the northeast, but from the north, yeah, what is given 40 degrees, the north of east means from east it should we should take 40 degrees. So from east it is making angle of 40 degrees. Next, the third force is 10 newtons acting 50 degrees in the west of east. So in the west east direction. So east of west direction we should take the 10 newtons is acting. But however the angle is given as 50 degrees in west of east, means again from the east it is 50 degrees. So in the west east direction, that is so 10 newtons in the direction, and it is making an angle of 50 degrees from the west of east. So here west of north, I think. So you should mention the not west of east. So west of north here. So from north it is 50 degrees. So it is acting, the 10 newtons is acting in the west of north, that is northwest direction, and making an angle of 50 degrees in the west of north, means that it is making an angle of 50 degrees with north. Therefore, the same force is making an angle of 40 degrees with west, because the total angle is 90. So 90 minus 50 will become the 40 degrees. So like this. And the fourth force is already mentioned, a force of 30 newtons is acting vertically downwards, or sometimes acting due south. This is nothing but the force acting due south. So F4 is equal to 30 newtons. Now because the force diagram, and now we are required to find out the resultant of this force system by resolving the forces horizontally and vertically. Now firstly, resolving the forces horizontally, the sum of the horizontal components of all the forces is equal to, here the first 20 is acting the rightward positive, plus 25 into cos 40, and here minus 10 into cos 40. That's all. So the value is 31.49 newtons. Next, the resolving the forces vertically and finding the algebraic sum. The algebraic sum of the components of the vertical forces sigma v is equal to, if you see the figure, so 25 into sin 40 plus 10 into sin 40 and minus 30. So it becomes the minus 7.5 newtons, and the negative sign will indicate the force acting in downwards. In the sigma h, it is positive, so it is acting in the rightward direction. Now coming to the resultant force, the resultant is equal to sigma h square plus sigma v square, and substituting the values, we will get the R is equal to 32.37 newtons. Similarly, the theta is equal to direction resultant, theta is equal to tan inverse of sigma v by sigma h, that is equal to tan inverse of 7.5 by 31.49. It is equal to 13 degrees 23 minutes. Now we can show this. So the magnitude is equal to 32.37 newtons, and it is acting. So the angle is given as 13 degrees 23, but we don't know whether it is acting. If you see the, that is a resultant force diagram in figure C. So sigma h is positive, so rightward, and sigma v is negative, that is downwards. So the R is making an angle of, that is 13 degrees with x axis. So that is lying in the fourth quadrant. But so now to find out the equilibrium, then we have to, what we should do, what should we do now? We have to action the line which is opposite to that of the R. So if you construct a mirror image of the R, so that is E. So like that, and it also makes an angle of same 13 degrees 23 minutes, but in the second quadrant. So here the one important thing is that the resultant force is acting in the fourth quadrant, and the equilibrium is acting in the second quadrant. So in the present problem, we are supposed to find out the equilibrium. Therefore, so first we have found the resultant and the magnitude is same only for direction. So we have constructed this figure, and here the equilibrium is acting in the second quadrant and it is making an angle of 13 degrees 23 minutes in the north of west direction. So this is the equivalent force and this is the answer. Now coming to the summary part. In this lesson we have solved some problems on the resolution of forces and also Lami's theorem. And like this you can apply the same principle to solve the problems in the other situation. Now coming to the quiz part. Two forces of magnitude 30 newtons and 40 newtons act at right angles at a point. The magnitude of the resultant force is equal to, when they are acting at right angles, the resultant is equal to under root of the 30 whole square plus 50 whole square. It becomes the 50 newtons. So option A is the answer. Now the second question. The vertical and horizontal components of a particular force are 5 newtons and 12 newtons respectively. Then that force is, if you know the vertical and horizontal components, the resultant is equal to R is equal to under root of the sigma Fe whole square plus sigma Fh whole square, that is under root of the 5 square plus 12 square, that becomes the 25 plus 144, it becomes under root of 169. So under root of 169 is equal to 13. So the resultant of that force is equal to that is nothing but when the components are given, the force is equal to 13 newtons, and option C is the correct one. Now this is an assignment given to you, and here the forces are acting like this, and here the angle between the forces are given. However, you draw the imaginary x-axis and y-axis, and you should take the angles only from x-axis, and you have to resolve the horizontal components and the vertical components, and accordingly you need to find out the resultant of the given force system. So this is about today's lesson. It is the lesson about the solving the problems on the Lami's theorem and also the resolution forces. So thank you all. Thank you all of you.